this video, I'm going to talk about how we configure YFN&GPU sim, and especially I want to discuss why we do not use a configuration file. So we discussed why code is better than a configuration file. So typically we use a configuration file for configuring a simulator and configuring what's the hardware that we're simulating. Typically, the configuration file itself is very long. We have been written configuration files that is thousands of hundreds of lines or millions of lines long. And it actually has very limited flexibility. We can only configure systems that are allowed by the programmer who developed the simulator. If the simulator developer doesn't provide the flexibility for us to configure a system, then we cannot configure a system in that way. For example, if we want to configure a big little GPU, now we really need the developer to provide us the flexibility to define that one GPU is larger while the other GPU is smaller. So we cannot use these common parameters such as number of compute units per GPU to configure the system. And it's actually very error prone. We may very likely to make a minor mistake in this very long configuration file. And sometimes the simulation may even run to the end and get a correct result, only getting a wrong timing result. And there's no way to know if this result is correct or wrong. Also, the lack of tooling support. We have to write code in a domain-specific language that is either in a JSON file or INI file that is defined by the simulator. And typically, we do not really have the tooling support so that we cannot really do line-by-line debugging. So the parsing is actually very difficult. So as a programmer, you have to write a very, very long code to parse the configuration file you need to validate the configuration file. And sometimes in our past experience, we typically write a Python script just to generate a configuration file, which is very annoying. And so since we write a program to generate a configuration file, then the other program read that configuration file to turn it into structs. Why not we just use code to directly manipulate those structs so that we can configure the hardware under simulation the way we want. So we propose that we need to configure with code so that we can configure the system with the same program language as we developed the simulator. And it's even debuggable so that we can use a break line debugging tool so that we can parse what is going on in this configuration part of code. And also we have nice tooling support. We have syntax highlighting, and we have this debugging tool support, that we can even profile this type of configuration system. And also we can use these conditions and loops which significantly simplify the configuration process. And also people talk about configuration files because they want to make sure this result is reproducible. So that if you ship this configuration file to another researcher should be able to use this configuration file to generate a similar result. But what if this simulator evolved to a next version while the configuration file is designed for the previous version? We may still get a different result. So if we configure with the code, then we can keep the binary or the source code unchanged, so that we can ship this source code or the binary simulator to another researcher. Then another researcher can reliably reproduce the result. So in this way, we define the configuration file as just directly using the Go code. So how we build a system in YFN&GPU sim? We define builders. At the beginning, the main function may use a runner. A runner actually contains two aspects. One is the platform, which is the hardware under simulation, and one is the benchmark. The benchmark itself is the program to run on the simulated platform. And to build a platform, we use a platform builder, which builds each GPU and the interconnect between the GPU. It also builds the MMMU unit. It also builds the driver. And the platform builder needs to call the GPU builder to build a GPU. And it also calls things like a PCIe connector to connect these GPUs together. When we want to build a GPU builder, we call this compute unit builder to build each compute unit. And we can also call these cache builders to build each cache component. And what if you want to modify this builder system? Do you need to modify this? Do you need to modify this builder? So we encourage you to copy and paste the existing builder and to modify that the copy paste the duplicated builder. So how to prepare your experiment? So suppose you create a special L2 cache and you want to integrate this L2 cache together. So what do you need to do? You need to replace the runner so that you can use a platform builder. And you need to use a new platform builder so that you can build a new GPU, so that you can invoke a new GPU builder. Then you need to replace the GPU builder to invoke your new L2 cache builder. And you still need the old CU builder and the cache builder for the L1 cache, so that you build this compute unit, you build L1 cache, and you build your new L2 cache, and then combine them in a particular way within the GPU builder. So this is how would you prepare an experiment with this builder system. Depends on which level you want to modify the simulator. You may copy different type of builders, different layers of builders to your project.